In the southern city of Ulm, in the then German Empire, the man known to history as Albert Einstein came into this world on March 14, 1879. Ulm was the capital of the Württemberg Kingdom, which comprised a substantial portion of the late 1800s, when Germany was a federal state. Hermann Einstein was born in Buchau, Württemberg, to Ashkenazi Jewish parents. When Hermann was a student at Stuttgart, the capital of Germany, he was very bright and shown great talent in applied mathematics. Worcester, when he was young. Unfortunately, Einstein had to drop out of school in the 1870s to help support his impoverished family, so he worked at the featherbed store in Ulm, owned by his cousins Moses and Hermann Levy. German-Jewish Pauline Koch was Albert's mother. Her family had deep roots in Württemberg's merchant and purveyor communities. Albert was born to her marriage to Hermann Einstein in 1876. Maya, or Maria Einstein, a daughter, was born in 1881, 2 years after that. The financial operations of Albert's father had a significant impact on Albert's upbringing. The Einstein family relocated to Munich when Hermann was a little boy, on the recommendation of their brother Jakob, who was a successful businessman. Situated about 170 kilometers east of Ulm, the biggest city in southern Germany. When Jakob and Hermann were trying to launch an electrical engineering firm in Munich in 1880 under the name Einstein & Co. This happened just when the Western world was on the cusp of entering the great age of electricity. Before being moved to the Luitpold Gymnasium in Munich in 1887, Albert attended a Catholic primary school there. Up until 1894, Albert stayed put, but when again forced to leave their home, this time by the failure of Hermann and Jakob to acquire a contract to start electrifying Munich. Rather, they made their way to northern Italy, where they eventually settled in Pavia and Milan. Albert stayed in Munich for a little longer to carry on. He started out enthusiastic about his studies at the gymnasium, but after a few months, he got disillusioned with the regimented curriculum and managed to persuade his parents and the school administration to allow him go to Italy. From 1894 forward, Albert pursued further study in Italy. Despite his father's wishes for him to pursue a career in applied engineering and join the family company, he was displaying clear indications of an early aptitude for science and mathematics. He had been a teacher at Munich during the summer of 1891, independently studied Euclid's advanced geometry and algebra. The Einsteins hired a private teacher named Max Talmud, who was very accomplished in the areas of ophthalmology and optometry, to instruct young Albert in advanced mathematics. As well as scientific concepts, he quickly discovered that his ward was surpassing him in proficiency in areas like geometry, algebra, and calculus. Additionally, he wasn't a genius who had an insatiable appetite for all things mathematical and scientific. Even as he approached puberty, he devoured the works of prominent thinkers in philosophy from the 18th and 19th centuries, most notably the German Enlightenment thinker Immanuel Kant. The first publication of Kant's Critique of Pure Reason. It is one of the most complex philosophical tracts ever written, providing one of the most analytical treatments of metaphysics, the study of reality, in 1781. However, Albert seemed to have a thorough understanding of it at the age of 14, which perplexed his professor. Everyone from young Einstein's instructors to his private tutor and parents took note of his exceptional talent. Thus, he was sent to take the admission tests at the Swiss Federal Polytechnic School in Zurich immediately after his 16th birthday and after arriving in Pavia, a prestigious institution for graduate study in the STEM fields. Due in part to his youth, Albert was not accepted at this time, despite his outstanding scores on the technical tests. The Swiss Matura was passed the year after that by him, a Swiss equivalency test for those who did not finish secondary school in Switzerland, but wanted to finish it in another country. To evade mandatory military duty, he had already relinquished his German citizenship earlier in the year, among the nation's youth. He was 17 years old when he eventually enrolled at Zurich's Polytechnic School in the fall of 1896, despite the fact that he was a stateless person. The two fields in which he had previously shown promise, mathematics and physics, would be his focus there, a remarkable talent forever when he was a little boy. After 4 years, in 1900, he earned a certificate from that institution. His scholarly interests started to take shape during Einstein's time in Zurich. His scientific interests were wide-ranging, and he was developing into an eclectic scientist. While he could be loosely classified as a physicist, his work encompassed many different areas, including quantum mechanics, the study of small-scale physical phenomena, the broad science of detailing the atomic and subatomic level, physical characteristics of the natural world. Furthermore, he was anxious to determine the speed of light. While he was starting to delve deeply into this topic around the turn of the century, according to the experts in Zurich, much of Europe and North America believed that light could only move in wave patterns. Later in life, it became apparent that Einstein had doubts about this theory and thought there was another level of complexity, inside way, that light was able to travel. During his mid-20s, Einstein dedicated his studies to these and other areas of advanced physics. They were the meat and potatoes of his PhD thesis, A New Determination, which he worked on in Zurich from 1905 to 1907, while working as a part-time student in the early 1900s. In terms of molecular aspects, Mileva Maric, a young Serbian physicist and mathematician who had started at the Zurich Polytechnic School around the time Einstein had first been awarded teaching hours there after graduating top of his class, seems to have assisted him in his studies in the early 1900s. Year 1899 for the class. There were just 2 female students there, while Maric was a student there. She began dating Einstein shortly after they met, and it is widely believed that she had some hand in his scientific work. It is not apparent to what extent she accomplished this. Whatever the case may be, she became pregnant in the summer of 1901, which cut short her own studies. Having a kid outside of a marriage was still seen as a social scandal at the time, and Einstein and Maric had not yet tied the knot. It seems that Mileva went back to Serbia to deliver the baby, who they addressed as Liesel in their postpartum letters. It is unknown what became of her thereafter. She may have died in 1903 from scarlet fever, according to some accounts, although other accounts claim she was located in Serbia and ready for adoption. The fact that Einstein and Maric were married in January 1903 makes her death all the more probable. 2 more sons, Hans Albert, born in the summer of 1904, and Eduard, born in 1910, would follow in their footsteps. After finishing his diploma in Zurich in 1900, Albert had a difficult time finding a teaching job, which seems strange looking back. He wasted the following 15 months attempting to get a junior-level teaching and research post at a university in Central Europe. Meanwhile, in 1901, he became a citizen of Switzerland, achieving statehood after half a century of being nominally unattached to any country. An acquaintance and family friend of mine from Zurich's Polytechnic has just become a Swiss citizen. In order to get a position for Einstein at the Swiss Patent Office in Bern, Max Grossmann sought out his father's assistance. In this role, Einstein assisted the patent examiner. In essence, this meant that Albert was assigned the responsibility of evaluating the viability of inventive concepts and technologies that were submitted to the patent office by persons seeking recognition of their intellectual property rights so that they might receive financial compensation and acknowledgement for their work. It was there that Einstein spent the following few years. In addition to providing for his small family, his work revolved on various electrical conduction and mechanical devices, which may have influenced Einstein's early studies. Years. The narrative of how Albert Einstein rose from relative oblivion in the scientific community of the industrialized world to become a leading physicist in Europe in the mid-19th century is one of the most bizarre in scientific history. In the early 20th century, while he was working as a patent examiner in Bern and finishing his doctorate, Albert Einstein was preparing a number of articles to be published in the prestigious German academic journal Annalen der Physik, beginning in 1799 and beyond. 4 individual study articles were subsequently published in the journal in 1905 as a consequence of this. They each made significant contributions to different areas of physics research. Taken as a whole, they are seen to symbolize a watershed moment in the history of modern physics and a paradigm shift in how humans view the atomic and molecular components of the natural universe. That is why most people refer to 1905 as history of Western science, and Einstein biographers refer to this period as the miracle year of his career. On a heuristic viewpoint concerning the production and transformation of light was the title of the first of 4 1905 papers written by Einstein, which came out on June 9th. This provided the first comprehensive explanation of the photoelectric effect. When light or other electromagnetic radiation interacts with a substance, it may cause the photoelectric effect, in which electrons are released. The photoelectrons are the electrons that are released in this way. Before Einstein outlined this photoelectric effect in 1905, most scientists believed that light traveled like ocean waves, while light also traveled as what he called a limited number of energy quanta, which could only be absorbed or formed as entities because of the photoelectric effect. These quanta did not divide as they went. This not only clarified a lot of things that were never before understood about the properties of light and electrons, but which had crucial consequences for comprehending how a certain frequency of light might provide enough energy to release an electron. This was an expansion of previous research by physicists. Einstein's work provided a wealth of fresh information on the photoelectric effect, which had previously been known only via the work of scientists like Max Planck. This has far-reaching consequences for real-world applied physics. And even now, after all these years, Einstein's work was openly referenced in his Nobel Prize in Physics acceptance speech, even though his results were not universally acknowledged by physicists until the mid-1920s. This second article by Einstein from 1905 was published just 6 weeks after the previous one, and it was named "On the Motion of Small Particles Suspended in a Stationary Liquid, as Required by the Molecular Kinetic Theory of Heat," was published in Annalen der Physik on July 18th. No precise method of determining the size of molecules existed before Einstein's study. Nevertheless, a number of 19th century scientists, including John Dalton, had observed that chemical compounds exhibited a tendency to mix or break down in weighted quantities, suggesting that they were all composed of a universally identifiable physical molecule. Atoms are the modern name for these solitary molecules. The term originated with Greek philosophers in the 6th century BC, who were also trying to make sense of the universe some 250 years before Einstein lived, using what was then known as Brownian motion. Particles in this example pollen, floating in a water solution, Einstein demonstrated in his second 1905 work how these atoms might be monitored more extensively. The document written by Einstein and a supporting Jean Perrin, a French physicist, conducted research in 1908 that proved beyond a reasonable doubt that the building elements of reality were atoms and molecules. Therefore, this second article from 1905 greatly aided in the general public's acceptance of the discovery of subatomic particles and their role in the formation of the atomic hypothesis, which became the backbone of most of the physical sciences in the 20th century. A little over 2 months later, on September 26, 1905, Einstein had his third work published. On the Electrodynamics of Moving Bodies was the title, and special relativity was the subject of this. James Clerk Maxwell, a Scottish physicist and mathematician, came up with an equation in the early topics related to magnetism and electricity in the 1860s. Near the speed of light, Maxwell's equations caused physicists to rethink their understanding of mechanics. Given this issue, Einstein proposed his special theory of relativity, also known as special relativity, in his 1905 conference paper. This proved that no matter how fast or slow the light source or the observer are moving, the speed of light remains constant. Contrary to what had been proposed, too. Since the speed of light is not constant, as stated centuries ago by Isaac Newton. Furthermore, it is not possible to tell which of two objects is moving relative to the other when light is involved. This was a valid assumption of Einstein's special theory of relativity. Does not constitute. While seeing the city's central clock tower from a streetcar in Bern in the early summer of 1905, Einstein had this epiphany. In the event that his vehicle unexpectedly began, as Einstein and the clock in the streetcar were both traveling at the speed of light, the clock arms on the clock tower would seem to have stopped abruptly, while the clock inside the vehicle would continue to move around as if nothing had occurred, moving at the same speed. Consequently, the pace of travel was relative. Just because the streetcar seemed to come to a complete halt with relation to the speed of light doesn't imply the clock tower really came to a complete stop, at which the streetcar was now moving. This demonstrated the operation of special theory of relativity. On November 21st, Einstein released his fourth and last article from his Annus Mirabilis, titled, "Does the Inertia to the Energy Environment in which it is located, paper, E equals mc squared, is well known." What this says, in a nutshell, is that the energy, E, of a massless body at rest is equal to m times the speed. Radiated light, the equation's c squared. This equivalency equation demonstrated that a large particle has an energy, or rest energy, apart from its kinetic energy. It was then dubbed the mass energy. Similarly, it is emphasized that a particle's rest energy, like an atom's nucleus, may be so large that it would cause the release of a vast quantity of thermal and light energy if the particle were to be sufficiently disturbed. We will show that Einstein came to lament this part of his study, since its practical application had disastrous effects in subsequent decades. In 1905, Einstein released 4 articles that were more than just groundbreaking. Academic theoretical physics's closed-off realm. The scientific methods used in the subsequent decades were influenced by his work. As an example, when you approach a modern automated door and it opens for you, this is due to the fact that the doorway sensors respond when a moving person blocks the photons in the light beams that they produce. The door is instructed to open by the sensor. First, Einstein described the behavior of photons. Some of the advancements that sprang from his research on light include solar-powered calculators and automated streetlights that switch on when it becomes dark. One of the ideas that paved the way for GPS was the special theory of relativity. Global positioning systems, GPS, at various points in time. So, Google Maps is drawing on some of the research that Einstein released in his Annus Mirabilis papers when you turn it on. Furthermore, when nuclear power plants release enormous huge quantities of energy by using the potential energy inside an atom's nucleus, they are doing this in accordance with Einstein's findings on the equivalence of mass and energy, as stated in the equation E equals mc squared. Groundbreaking discoveries made by Einstein. The European scientific community took notice of the 1905 publication shortly after its release. However, it took a few years for the publication to reach its target audience, since researchers back then relied on word of mouth and the physical distribution of academic publications. The significance of his discoveries to be understood all around Europe. They changed the course of his career in doing so. His tenure at the patent office came to an end in 1908 when he secured a teaching job at the University of Bern. He was given the position of newly established chair of theoretical physics at the University of Zurich the following year. For the following 2 years, he stayed put. He spent this time honing some of the arguments he had put forward in his papers from 1905, as he continued to build upon his work on special relativity and started to formulate the theory of general relativity as a branch of it. Gravitational pull between masses is said to be caused by space-time distortion, according to general relativity theory. Throughout that period, by the two groups. Black holes and other cosmic mass objects have benefited greatly from this study's early findings. After working in Switzerland for more than 15 years, Einstein decided to leave for a new job in 1911, which he had been extended at Prague's Charles Ferdinand University, the oldest institution of higher learning in the Czech Republic, then a part of the Austro-Hungarian Empire. The offer of Austrian citizenship came at the same time. Despite only being there for little over a year, he managed to crank out over a dozen publications covering subjects including quantum theory, gravity, and the mathematics of radiation. He returned to Switzerland not long after accepting a new offer. The Polytechnic School in Zurich, where he had previously studied, extended an offer to return as a professor. By the summer of 1912, he had arrived, and for the following year, he would both investigate and lecture to students that were becoming more and more acquainted with the rising star of the German scientist. Issues related to molecular heat and gravity. Marcel Grossmann, an Einstein colleague from Switzerland, who had attended the Polytechnic with him in the late 1890s and whose family had helped him get his previous job at the Bern Patent Office, was essential in a lot of this latter work. Einstein was visited in Switzerland in the spring of 1913 by two of the leading scientists of the day, Max Planck and Walter Nernst. This was less than a year after he had taken up his job in Zurich. Both had jobs in Berlin and had traveled to Zurich to try to persuade Einstein to go back to Switzerland. He was born into to accept a post at Berlin's university. With the position came the responsibilities of director of the Kaiser Wilhelm Institute for Physics and automatic membership in the Prussian Academy of Sciences, Wilhelm Institute for Physics and automatic membership in the Prussian Academy of Sciences. Because of this, Einstein would be free to form a research team and devote himself fully to his work. It was an irresistible offer, and the thought of spending more time with his cousin Elsa, a German, with whom Einstein had started communicating regularly in the spring of 1912, only added to its allure. So, Albert moved to the German capital in the beginning of 1914. Mileva, his first wife, and their two kids, first consented to relocate to Berlin. However, she quickly became uncomfortable there, saw that Albert was developing a strong bond with his cousin, and ultimately opted to go back to her husband's hometown. They brought their children to Zurich. They stayed apart until their 1919 divorce, after which Einstein wed Elsa. They were both well into their 40s at this point in Einstein's second marriage, was unsuccessful in producing any more offspring, although Albert did become a stepfather to Elsa's 2 girls from her first marriage. As soon as Einstein touched down in Berlin, the First World War broke out. A number of factors, including colonial animosity in Africa, the void created by the Ottoman Empire's fall from power in the Balkans, and the naval arms race between Germany and Britain, had contributed to the escalating tensions between the main European powers for some time. In the summer of 1914, these factors came together to spark a war that quickly spread throughout the globe, starting in Europe. It caused a ruckus when Germany invaded neutral Belgium to launch a swift attack on northeastern France. Manifesto of the 93, a statement addressed to the civilized world, and quickly disseminated in Germany in response to worldwide censure. Figures such as Nobel laureate Adolf von Baer, 1905, spearheaded the movement. Paul Ehrlich, a chemist, and 1908 Nobel laureate for his groundbreaking work in chemotherapy, and scores of other eminent German academics effectively signed a statement expressing their support for Germany's war effort. For his part, the lifelong pacifist Einstein collaborated with other German academics to draft the Manifesto to the Europeans rather than sign it. This was an expression of the belief that the shared cultural heritage of Europe might be used to ending the conflict quickly. Their dreams would remain unfulfilled as the war dragged on for another 4 years of seemingly endless fighting, accompanied by years of upheaval and civil strife over much of the continent. From 1915 onwards, when the first shock of the advent of the war subsided, Einstein was able to begin fresh research in Berlin in a coordinated way, despite the continuing conflict. Last but not least, the Kaiser Wilhelm Institute did not come into being until 1917 in Berlin, under the direction of the late Albert Einstein. Its launch was postponed due to war-related funding and administrative setbacks. For the following 16 years, he would preside over the institute. At the same time, he became a member in 1916. The oldest important academic group of physicists in the world, the German Physical Society, which had been founded in 1845. The years that followed were also filled with international recognition, such as being admitted as a foreign member to the Royal Society in 1921, and becoming a member of the Royal Netherlands Academy of Arts and Sciences in 1920. The oldest scientific society in the world, having been established in London in 1660, and often regarded as the most esteemed in the world. Putting these accolades aside, Einstein kept pushing the boundaries of knowledge in the mid-1910s. An example of his work is his 1916 theory on gravitational waves, which are in the curvature of spacetime, which causes ripples to occur. Although they were predicted by Einstein a century before their actual confirmation, in 2016, the instruments available in the early 1900s were unable to detect them, conducted by researchers in the United States. He was also starting to speculate about what we now know as black holes, which are regions of very dense space-time that warp both space and time, and from which no light nor particles can escape. His groundbreaking work on black holes, like his other groundbreaking work, allowed many of his successors to provide precise descriptions of the universe's building components later in the 20th century. On the other hand, he might also be incorrect. In 1917, he started developing a hypothesis that he called the cosmological constant. It postulated that the cosmos was static. After a long time had passed, and American astronomer Edwin Hubble had seen the universe's nebulae receding, Einstein came to terms with his believed that his idea on the cosmological constant was flawed, and often called it his biggest blunder in the field. Aside from that, his other major wartime research initiative was brilliant. A notion that Einstein had been developing for some time was theory of relativity for more than 10 years, and in 1905, he published a well-regarded study on the topic of general relativity. His work on general relativity was not completed, however, until the middle of the 1910s. A formalization of gravity's geometric theory was provided by general theory of relativity. The explanation of gravitational attraction and the whole intricacy of geometric gravity as it pertains to the cosmos, rather than simply individual objects, went much beyond Newtonian concepts of gravity. Celestial bodies. The question of who came up with the general theory of relativity first is still being debated today. David Hilbert, a German mathematician who lived during Einstein's time, came to almost the same conclusions as the great scientist in the halfway through the 1910s. There was contact between Einstein and Hilbert, much as there was between Charles Darwin and Alfred Russel Wallace, who simultaneously established the theory of natural selection in the mid-19th century. Additionally, in 1915, Einstein paid a visit to Hilbert's workplace at the University of Göttingen to give lectures on his own research. Almost beyond a doubt, the mutual impact between Einstein and Hilbert was so great that they both reached the identical conclusions. In the winter of 1915, on separate but related topics pertaining to general relativity. By the end of 1918, the First World War had begun to recede from Europe and the rest of the globe. However, in some nations like Ireland, Russia, Turkey, and Hungary, the end of the war had not yet come. Tragic civil conflicts sprang out in many nations throughout the war, surpassing the horrors of the conflict itself. Academic conversation continued in full force, and findings started to be widely disseminated again, as life returned to some normalcy. Working together, Einstein and Hilbert developed the general theory of relativity was more widely discussed among physicists in the United States and Europe. The revolutionary nature of their research became more apparent as time went on. Afterwards, at the height of July 1919, the notion was the accuracy of this during a solar eclipse was verified by the English mathematician and astronomer Sir Arthur Eddington. This time, the mainstream media ran with the narrative, stating that Einstein's theory had debunked Isaac Newton's universe model from over 250 years ago. Considering all of this, it is perhaps not surprised that Einstein was awarded the Nobel Prize for Physics in 1921 by the Nobel Foundation in Stockholm. In his 2004 publication, he was singled out for credit for developing the photoelectric effect. Nominations for the prize might have been made for any number of studies conducted throughout the preceding 15 years, not just 1905. The world's opening up during the boom period and receiving the Nobel Prize in 1921, in the 1920s. Following a long period of conflict and social unrest, Einstein and Elsa, his newlywed wife, decided to do a world tour. They arrived in New York City in early April of 1921 via ship, and the pair was welcomed by the in attendance were the mayor, John Francis Hylan, and a group representing prominent Jews in the city. New York's Columbia University and New Jersey's Princeton University hosted weeks of talks and celebrations thereafter. In the White House, Einstein visited with President Warren Harding later that month. After that, they set sail for Japan's imperial court in the Pacific, Singapore, India, and finally the Middle East. Near the conclusion of World War I, The Jewish Zionist movement was trying to found a new state for the world's Jews after centuries of dispersion, and Einstein went there to see Palestine, which had become a British mandate. After that, he went back to Germany. But that journey from 1921 to 1922 was the first of a series of major journeys to various regions of the globe. For example, he spent many weeks in Brazil, Uruguay, and Argentina on his 1925 South American tour, nations that had social and economic prosperity at the turn of the 20th century, and where Einstein was highly esteemed by scholars. During the mid-1920s, Einstein was embroiled in a highly publicized scientific controversy. He was engaged in a debate with Danish scientist Niels Bohr, who had received the Nobel Prize in Physics in 1922, just 12 months after Einstein, for his work in the field. By the mid-1920s, Einstein and Bohr had already begun to argue about their quantum theory and its competing interpretations. The fact that Bohr still didn't buy into the reality of photons, which Einstein had postulated in 1905, was at the heart of the matter. Until 1925, when their arguments continued, he refused to acknowledge their existence. He mattered. Until 1925, when their arguments continued, he refused to acknowledge their existence, disregarding other aspects of their divergent perspectives on quantum physics. A renowned intellectual debate took place in 1927 at the Fifth Solvay Conference at the International, after debates had taken place in London and other places from 1922 to 1925. Small A Institutes of Chemical and Physical Sciences in Brussels. Here the argument between Bohr and Einstein resumed, with both scientists presenting arguments that were later shown to be correct. Be that as it may, going beyond the theoretical notable among the attendees at the conference were many of the most eminent physicists from across the globe. In addition to Einstein and Bohr, 17 of the 29 participants had either earned or were to win Nobel Prizes. Among them were Erwin Schrödinger, Marie Curie, and Werner Heisenberg. What this proves is that the scientific community in Europe during the interwar era was very brilliant. On the other hand, Einstein rethought the cosmos according to his own ideas. This was in reaction to what is now known as Hubble's law, which was found by American astronomer Edwin Hubble on the recession of nebulae. According to this, galaxies are receding, traveling away from Earth at velocities that are directly proportional to their distance from the Milky Way. As a result, a celestial body's speed, relative to Earth's will, increase as its distance from the planet grows. These results, which were released to the public, prompted Einstein to give up his then current explanation of the world, the cosmological constant, in 1929. This theory assumed that the cosmos was mostly static with respect to its expansion, i.e., that the universe has been expanding at a rather consistent rate since the Big Bang. The fact that the cosmos was clearly expanding at an exponential rate became apparent due to Hubble's findings, which prompted Einstein to rethink his theory. Faster and faster. Einstein's choice to return to the United States in December 1930 was influenced in part by Hubble's finding. In 1931, he fulfilled his desire to see Hubble and express his gratitude for his study. Although Einstein supposedly traveled to California to accept a 2-month visiting fellowship at the California Institute of Technology, more commonly known as Caltech today, the trip is mostly recognized for his visit to California. In a disturbing comment made on his journey, Einstein implied that science may do more damage than good to human society. This was likely a reference to the growing use of technology in combat, which the pacifist Einstein despised. During his visit to Los Angeles, Einstein met author Upton Sinclair and actor Charlie Chaplin. both of whom had publicly declared their pacifism. Their shared distaste to the increasing militarism of the 1930s likely contributed to their friendship. As their relationship blossomed, Einstein went to see Chaplin's new silent picture, City Lights, which helped launch the romantic comedy subgenre in Hollywood. When the Einstein sons, Albert and Elsa, joined the Together with Chaplin, Einstein received the same acclaim as any Hollywood legend. It was the start of a lengthy relationship between Einstein and Chaplin, which led to Chaplin visiting Einstein's residence in Berlin not long after, and Einstein rekindled their friendship upon his own return to the United States at the beginning of 1933. The political climate in Einstein's home country of Germany was shifting for the worse throughout the 1920s and 1930s, while he was busy traveling the world and holding down posts there, thanks to his rising star power. Much worse. After a period of political turmoil after World War I, Germany began an era of noticeable prosperity and instability, beginning in 1923. That fell apart at the end of 1958, 1929, as a result of the Stock A tremendous economic downturn swept throughout the industrialized globe when the markets on New York City's Wall Street collapsed. Massive unemployment and insecurity led a large section of the German populace to cast ballots in the country's national elections to Adolf Hitler and the notoriously anti-Semitic National Socialist German Workers' Party, Nazis. After becoming Germany's biggest political party in the 1932 Reichstag elections, Hitler rose to power in early 1933, Chief Justice of the land. Germany became a fascist one-party state within weeks of the party's formation. The Jewish population of the nation and famous Jews like Einstein found this very disturbing. While in America, he made up his mind not to come back. Following a short stop in Antwerp, Belgium, when Albert renounced his citizenship and turned in his German passport to the German consulate, the Einsteins relocated in the United States instead and secured a post at the Princeton University's Institute for Advanced Studies in Princeton, New Jersey. With the exception of a directorship at Massachusetts's Brandeis University in the mid-1940s, Einstein was mostly affiliated with Princeton throughout the most of his career, what was left of his life. Here on the East Coast of America, Einstein did some further significant work in the mid to late 1930s. Working with Jewish artist Nathan Rosen led to a very substantial partnership. American physicist Rosen and Einstein collaborated to create a potential wormhole model. Wormholes are hypothetical constructions that might potentially link different locations in space-time. Although Einstein and Rosen's theoretical wormhole bridges were revolutionary when they were first proposed, they are now cornerstones of space travel theory. Finally, they became a cornerstone of scientific inquiry, works of fiction published after the mid-century. Back in Germany, where Einstein was a professor in the 1930s, events were unfolding that would have far-reaching consequences for the world at the time. After seizing power in 1933, the Nazis made it plain that they intended to reverse the Treaty of Versailles, which ended World War I. They started recruiting hundreds of thousands of troops to rearm Germany in the mid-1930s. Joining the military and constructing a fleet of thousands of combat aircraft, bombers, and tanks, the Nazis then began use diplomatic pressure to annex Austria into Greater Germany in the spring of 1938 and to acquire land from other countries like Lithuania and Czechoslovakia. Afterwards, in September 1939, after Hitler's invasion of Poland, France and Britain decided they could no longer tolerate the Nazis and went to war with Germany. President Franklin Delano Roosevelt's administration did not have public assistance for the United States' engagement in what was seen as a conflict in Europe that it ought not to get involved in. On the other hand, In December, the United States Pacific Fleet was attacked while it was in Pearl Harbor in Hawaii by Japan, an ally of Germany. It wasn't until 1941 that the U.S. joined the war effort as well. Scientific advancements would have a greater impact on this conflict than on any other in human history. Despite his pacifism, Einstein found himself dealing with U.S. government letters regarding the escalating dispute. Actually, this started a few weeks before the European conflict broke out. The use of uranium in nuclear fission was discovered by European scientists in early 1939. This finding opens up the possible potential. The possibility of creating a nuclear weapon became ever closer. A group of scientists from Europe, headed by the Hungarian Leo Szilard, saw how feasible it was for a committed research group to create a nuclear bomb. A lot of scientists in Europe were worried about this because a lot of top physicists from Europe worked in Germany. They could be swayed to help the Nazis build a nuclear weapon, which Hitler and his cronies would use as a conventional weapon of war, despite its completely devastating potential to kill people. As a result, Szilard and two other Hungarian scientists, Edward Teller and Eugene Wigner, sent a letter to the U.S. government that warned of the dangers of the Nazis creating a nuclear weapon, nation-state weaponry, before theirs. After arriving in the United States, Einstein added his signature, and it was then forwarded to President Roosevelt's administration. In the months after its publication, the document now known as the Einstein-Szilard letter had a significant impact. When the United States began its own nuclear weapons development program, initiated piecemeal in late 1939, only weeks after the Einstein-Szilard letter was received, the Manhattan Project was the U.S. government's endeavor to build a nuclear weapon. This went against Einstein's own pacifist tendencies, but he had to warn the government about the risks of the Nazis getting their hands on such a weapon before the U.S. did. This being said, he considered war in general to be a sickness that contemporary civic society as a whole need to fight against. Consequently, he was not involved in any way with the actual Manhattan Project. Instead, American theoretical physicist Robert Oppenheimer served as its leader. After the United States' entry into the war in December 1941, money and resources skyrocketed, especially as it became clear that the Nazis were attempting to construct superweapons. Prior to this, its operations were relatively restricted from 1939 to 1941. For example, a nuclear weapon at many European sites, most notably in Norway, where heavy water, a kind of hydrogen with distinct nuclear characteristics, was being created. But study here was sluggish and foiled many times by sabotage operations undertaken by Free Norwegian fighters and British Special Forces, SEAL forces. The Manhattan Project had already employed more than 130,000 Americans at that point. Even as early as 1942, a nuclear reactor had been shown in Chicago. Midway through July 1945, in the New Mexico desert, the first nuclear bomb in the world was exploded. In the era after the first nuclear explosion, in Europe, the Second World War had ended weeks earlier. Nevertheless, due to the recognized Allied strategy of postponing the resolution of the war in the Pacific against the Japanese Empire until after Nazi Germany had been vanquished, even in the summer of 1945, fighting had not ended. As a result, President Harry Truman's government wasted little time deciding to use the new weapon against Japan, reasoning that this would lead to the eventual salvation of more than 1 million lives if it swiftly compelled Japan to capitulate. Thus, the first nuclear bomb was dropped on the city of Hiroshima on August 6, 1945, killing some 75,000 people on that day and another 60,000 or so in the months that followed, due to radiation damage. 3 days later, Nagasaki was hit by a second, slightly different sort of nuclear bomb, which killed over 80,000 people in the immediate area and in the aftermath. Though Japan capitulated quickly, the brutality of the assaults and their aftermath horrified Einstein. "The time has come now when man must give up war," he said shortly after the bombs went off. War as a solution to global issues is no longer acceptable. Later on, he regretted publishing his work on the world's molecular structure, as well as the ideas of mass energy and equivalency. In 1905, helped advance nuclear weapon research and development. After World War II, Einstein kept busy with research and publishing, but he was getting close to his 70s, so he was limited in what he could do due to health issues and the demands of his public profile. But when he was a Princeton student in the 40s and 50s, he worked on what would later be published in Scientific American as On the Generalized Theory of Gravitation, the foundation of his unified field theory. The goal of this unified field theory was to create a coherent theoretical framework that may explain the underlying laws of the cosmos and the natural world. Several physicists spent the early part of the 1900s trying to come up with such a unified theory. Unfortunately, not a single one of them had gained widespread support among academics. A single origin for all physical variables was postulated by Einstein's hypothesis, which sought to integrate aspects of his work on electromagnetic, gravity, and general relativity. Principles, a framework that could integrate fields like gravity, electromagnetic forces, and space-time curvature, the latter of which had occupied a significant portion of Einstein's research throughout the 1930s. In the end, his and others' labor, although his attempts to establish a cohesive theory were not successful. His work in this area is still seen as significant for the advancement of differential geometry, which is concerned with the study of the geometry of smooth surfaces and forms, especially in spaces. In the years after World War II ended in the United States, Einstein also became famous in popular culture, which was quite unusual for a theoretical physicist. To a large extent, this dated all the way to in the early Roaring '20s, when Einstein first arrived in the Big Apple. Just as Einstein was being awarded the Nobel Prize, his theory of relativity was being validated by other scientists, which altered our basic understanding of the cosmos. An article that appeared in the December 1919 edition of the New York Times claimed that Einstein had, quote, destroyed space and time with his scientific discoveries. This was a paradigm shift in human thinking, not seen since Charles Darwin's theory of evolution. 50 years before to the publication of his theory of natural selection, Einstein received enthusiastic praise for his work, while Darwin was accused of sacrilegiousness for his. Because of his increasingly famous looks and his connections to Hollywood greats like Charlie Chaplin, he became a someone who became increasingly well known in the years that came after. The most illuminating aspect of this is that by the 1940s, it was starting to become clear that Einstein's revolutionary theories were impacting society and the world in both theoretical and practical ways. Scientific theory. In the midst of all this, he rose to a status in American culture comparable to that of Stephen Hawking in the second part of the 20th century, or more recently, of James Lovelock and Richard Dawkins. There was a huge amount of writing and publishing done by Einstein by the time his professional life ended. While it may come as a surprise to some, Einstein mostly contributed to scholarly publications with his almost 300 articles published over 55 years, as opposed